I want to demonstrate, or at least give a brief introduction to electronics, embedded systems, IoT, and machine learning. And I really want to show people how, I wouldn't say easy it is, but how it's not as difficult as many people may think. And I'm also really want to demonstrate how you can learn this stuff, yeah, even without going to college. If for whatever reason you can't afford to do so, how you can easily self-teach yourself, simply because there is a plethora of information now available, certainly in books, but also if you can't afford books, as long as somehow you can get online, there's all the information that you ever need that's online right now. And electronics is a very practical thing, as is computer science and so forth, in that you just get on and you build using components. You can build a circuit, and you can see it manifest into that which you are trying to build right in front of your eyes as you build it. And so it's the same when you're developing software and writing programs to do certain things. You can write code and deploy it right in front of your very eyes. As long as you've got nowadays a cheap laptop, a smartphone, and you've got access to the internet, then there's a hell of a lot of things that you can do. Yeah. And, I constantly hear from people that they can't do this, that, or the other, because, if time isn't an excuse, then the other one is that they can't afford to get the components and so forth. So I'm going to show you how you can do all this stuff without paying a penny and doing it all online. So what I want to do is just do today a really simple demonstration on showing how to blink an LED. An LED, a light emitting diode. Yeah. For those of you who don't know what an LED is, a light emitting diode, it's a device that's considered a semiconductor because in its natural state, it's neither a conductor of electricity or an insulator of electricity. So if you can cast your minds back to science or physics at school, you learn the difference between a conductor and an insulator. Yeah, those of you who are still at school and haven't done that yet, you'll soon learn the difference between a conductor and an insulator. Yeah, I've got time to go into that right now, but hopefully I'll be doing a series of presentations on electricity, so you'll have a great understanding of what that actually is. So a semiconductor, as I said, is halfway between an insulator and a conductor, hence the word semiconductor. And that is, at one state, it acts like an insulator, and in another state, it acts as a conductor. And the way that it acts as a conductor is that when you apply a voltage to it, yeah, it almost seems like at certain voltages, low voltages, it seems like it's resisting the voltage, although what it is just hasn't started conducting yet. It needs a voltage, and the type of LED that we're going to be looking at using is a red LED, and a red LED needs a voltage of somewhere between 1.8 volts and 2 volts for it to start conducting. Yeah, and a certain amount of amps in order for it to conduct. Yeah, so we're going to be looking at our example is going to be using a red LED. So again, with that in mind, I'm going to get started. There's a lot more about LEDs. In fact, LED, light emitting diode, they're also a form of a diode. Yeah, and just like its cousin, the diode, the light emitting diode will not conduct also if it's in a particular direction. Yeah, it will only conduct one way. Yeah, whereas if we were looking at a piece of copper wire, it conducts either way, whether you turn it 180 degrees round the opposite direction, it will conduct, and vice versa. An LED, if you do that in one direction, it doesn't conduct; in the other direction, it does conduct. Yeah. Again, more about that in another session. So let's get started. So what I'm going to do, I'm going to fire up a virtual studio that allows you to build electronic circuits and also test them. So let's do that now. And I'm going to fire up Livewire. So if you give us a moment, I will do that. I've got to start sharing that. So guys, I want to demonstrate three methods, or should I say four methods, of controlling an LED that is blinking an LED on and off. I'm going to do three methods via hardware, complete electronics, and the fourth method I'm going to use both hardware and software, and that's controlling an LED via microcontroller. So let's start with the first three methods, and that's doing it electronically using discrete components. Now, the first and the most easiest way is to design a simple circuit with a on and off button where the user could actually switch manually the LED on and off. So let's try that right now. I'm going to need a maximum of about four components. So what I'm using is a piece of software that allows me to build electronic circuits, and I can simulate those particular circuits. I can build, test them, learn from them, and deploy them if they're functioning how I expect them and want them to actually function. So let's push along and quickly design this circuit up. So already I know I'm going to need some power, so I'm going to take a cell there. I know I'm going to need a ground. Here we go. We've got a ground. Right, let's go to passive components. I know I'm going to need a resistor. Got a resistor here. And finally, I know I'm going to need some form of output, which is going to be our LED. So let's pick our LED here. Okay, guys. Just going to make this slightly larger, just in case. Make sure you can see correctly. Okay, whoops. Where's it gone? There we go. Let's bring that down so we can, yeah. Okay, that's all I need, four components. Now, for this demonstration, I'm not going to really explain what these components do or explain the physics behind any of this. For those of you who don't know, this is just a quick demonstration to show you how I can control an LED. In further presentations, I will go into the physics and the electronics of these particular circuits and what they do and why it's doing, what it's doing and so forth. Okay, so for now, I'm going to make that 10 volts. So we've got a power supply of 10 volts. This resistor here, let's try to get it in line. So all I need to do now is just connect everything up. So this is your ground, that goes to our battery goes to our resistor, and our resistor goes to our LED, and our LED goes back to ground. So that's the circuit. Okay, we're going to change the value of our resistor. Instead of 1000 ohms, we're going to have it at 500 ohms. Okay, and again, I'm not really going to explain why I've done that and so forth. That will be explained in a later video. All you need to know that this resistor is a current limiting resistor, and when connecting an LED in a circuit like this, you always have to use a current limiting resistor. Okay, so that's about it. Let's switch it on. I should say the way we switch on is we press this run button, and that will simulate a circuit. And as you can see, the LED's on. Yep. But we want a blinking LED, so one that goes on and off, that we control manually. So the best way to do that, you probably all guessed by now, is that we use a switch. So let's see if we can find a switch. There we go. This is probably the best one, a push button switch. So if we get rid of this here, delete that, and in between that we put a switch. There we go. And we join this up. Oops. Again. Let's just so you can see it. Oops. Hard to control this. Yep. Great stuff. And then we switch it on. And then if I switch this is our switch. If I press it down, LED goes on. Take it off, the LED goes off. Push it down, the LED's on. Take it off, the LED's off. Push the switch down, the LED's on. Take my hands off the switch, the LED's off. And I can keep on doing that, and I can create this blinking effect by switching it on and off. So I'm just allowing it current to flow through, and then I'm not allowing current to flow through. And that's the blinking effect, yeah? But of course, that's been done manually. How can I achieve the same type of results, but without me having to constantly stand by a switch, switching it on and off? Okay, well, that can easily be done by another simple circuit. And in fact, I won't have to do too much alteration to this. So Let's first just get rid of this switch. Let's stop it first. Let's get rid of the switch. I'll delete that there. And our power supply, which is 10 volts DC, direct current, yeah, we're going to get rid of that, and we're going to replace that, yeah, with another power supply. And this time, our power supply will be AC, alternating current, and it's still going to be 10 volts. But this time alternating, there's going to be no switch, so we just connected the circuit without a switch. And so we've got alternating current that will alternate between plus 10 volts and minus 10 volts. Yeah. And as you can see, this squiggly line, it's showing you how the current moves, like what we call a sine wave. Yeah, sinusoidal. Yeah, so it's at one point, you can see here, it's 0, then a little bit of time later it becomes 5 volts, then 10 volts, then goes back down towards 5 volts, then it goes to 0 volts, then it goes to minus 5 volts, then it goes to minus 10, then it starts working its way back up from minus 10 to plus to minus 5 to 0 to plus 5 to 10 and so forth over time. It just keeps on changing its level of voltage. Yeah. So what we're hoping is that at some point, as the this voltage is going from plus 10 to minus 10, the LED will switch on and switch off. And the reason why we know it will do that is because the LED will only work at plus around about 1.98 to about 2.5 volts. You need at least that amount for the LED to work, for it to come on. And without that, it will not come on. How do I know that? Well, even before I do this, let me just do a quick test just to prove my point. Let's put this back in our DC cell. I'll take this out for now. Let's put this back in. Connect that back up. So it's direct current. And at the moment, it's set to 1.5 volts. Remember, I said around about the 2-ish, maybe 2.5, anything between 1.98 to about 2.5, it should start switching on. There's at 1.5, so technically this should not switch on. Let's run it and see if I'm correct. Okay, I've run it, and as you can see, there's no light. Let's increase this to, let's say, 1.99 and see if anything. 1.99, so that's close to 2 volts. Let's run it. So I'm running it, still can't really see anything. Yeah, so that's at 1.99. Let's increase it still further. Let's say 2.2 volts. 2.2 volts. And let's run it. Now you can see it slightly come on. Yeah. So we can see it's coming on around that 2.2 voltage. Let's make it 2.5. Just see what the difference is there. 2.5. And let's run that at 2.5. As you can see, it's even a little bit more on. Let's make it 5 volts, just so you get the idea. This way it should be fully on. 5 volts. Let's run that. And there you go. Yeah. So if we now put our AC voltage source back in, what am I doing? Let's find it. Let's put it here. We've got that 10 volts. So at some point, when that goes below 2.2, 2.1, down to 2 volts, that's going to switch off. Yeah. And then it's going to, as it travels all the way down, it's going to be off when it goes all the way down to minus 5, minus 10. And when it starts building its way back up positively, and then it goes 2 volts and goes 2.1, 2.2, around about the 2.2, it will start going on. Because this sine wave is moving so fast, at a hertz, 1 hertz, it's moving quite fast. We won't see it dim. We'll only really see when it's fully off and fully on. Yep. Let's see if that's correct. Let me turn it on. Let's have a go. There you go. See it going on and off. Okay. If you want to control the speed of that, you can control the speed via the frequency. Let's make this 10 hertz and let's see if it changes it any. As you can see, it's changed it. Oops, it doesn't like that. There you go. Let's put it back down to 1 hertz. Okay, there's another way we can also control the speed, and that's by putting another passive component in and that's called a capacitor. Let's take our capacitor out. Let's put our capacitor here in parallel. It's 1 microfarads at the moment. Yep. Let's change the value of that from 1 to 100, see if the speed changes at all. There you go. Slight change there. Let's change that to 1,000. You can see how it changes. And finally, let's 1,000. Let's do 100,000. Oh, 100,000. What's that? 10,000. Okay, 10,000. That's the final one I'm going to do. It's running at the moment, and you can't see anything. And I think that's because at the moment it's doing a thing where it's charging up the capacitor. Yeah. So it slowed it down quite a bit. If I was to show you how this looks visually, let's do a visual display just so you can see what might be going on. Hopefully it will show it. Let's do current flow, and let's do voltage levels. Okay, let's run that. Can you see what's happening? This the electricity is charging up the capacitor, and because the capacitor is so large, most electricity is on the capacitor before it goes anywhere close to the actual LED. Yeah. Now I can change that, as I said, simply by changing the value of the capacitor to make it still 0.1. Let's turn that on. As you can see, moving much faster there. Okay, guys. So that's another simple way of controlling an LED, blinking it on and off. And my third and final electronic circuit, which is a little bit more complex, we will be using an oscillator in order to switch an LED on and off. Okay, so let's try that. I'll stop that and delete these wires. I'll keep some of the components here because I'll need a couple of these components, just a couple of them. I'm going to need at least 6 resistors. I've got one already. Here's another 1, 2, 3, 4, and this will make the 6th one. 1, 2, 3, 4, 5, 6. Great. I've got the capacitor, I've got that. And one other extremely important component, that's our operational amp, or op amp for short. Okay, so bear with me for a moment. I'm going to build this circuit. You can just watch and see how I build it. Okay, this circuit is going to comprise of 2 different circuits combined to make one. It will have a circuit called a switch trigger and another one called an integrator, and that will allow us to create some oscillation where we can switch the LED on and off from the production of a square wave. Okay. As I said, bear with me as I sort this circuit out. Those of you that enjoy design work will certainly enjoy designing electronic circuits. It's quite relaxing, I must say. We're nearly there, guys. A few more bits to do. Okay, let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if we can get this to work. Okay, there we go. Let's see if We're nearly there, but not quite yet there yet. We need some power. Let's get some power, guys. It should be just here. It doesn't allow me to do that. Let's go around this way. Oh, what's he doing? What's he doing? Let's go here. This is quite scruffy. That'll work for me though. I'm looking through this, and I think we've designed a circuit fine. Now all we have to do is put the correct values on our resistors. I'm going to make that 10. 10. Make this 100. Make this one also 100. Okay, and I'll keep that at 500 ohms. And I think we're about there. Let's just change this to 10 microfarads, the capacitor at the moment, and adjust that later. And let's make sure our power supply is 10 volts DC. Okay, so I think we're there. Let's turn some animation on, just make sure we've got some animations. Oops, and one more. Current arrows. Okay, so that looks good to me, and I think we're good to go. Let's run it and see what we get. Hopefully it'll work first time. There we go. On, off, on, off, on, off, on, off. Okay, guys, so you can see our circuit working, and we're producing our own oscillation via this oscillator that we've created. And just like before, we can actually alter the timing by changing the values of the capacitor. You can see the charge building on the capacitor and decreasing on the capacitor. Yeah, these are the various different voltage levels we can see. Yeah, voltage levels. Yeah, voltage levels on the LED. At the moment it's 3.8. It goes down, goes up. Okay, so these types of simulation packages are great for building circuits. When you, back in the day, to simulate things, we would have to just write them down on bits of paper and do a whole load of maths formulas to try to work out what voltages and currents we're expecting at certain points. Nowadays, you can build these things up on these amazing bits of software packages, have a look, see what's actually going on with your circuit, make alterations and so forth, and it takes a fraction of the time that it would have done back in the day when you're trying to work these all out on pen and paper. So that's quite useful. And then when you've got it working exactly how you want it, then you can turn this in to a physical circuit by simply copying it and then building your actual circuit on a breadboard and then on a PCB, a printed circuit board, and so forth. Okay, I hope that helps. And so the next example I'm going to show you is using a microcontroller, and the family of microcontrollers that we're going to use are the Arduino, from an Arduino development board. And so you'll see both hardware and software working in unison to produce a blinking LED. Okay, I hope that helps. And so guys, what we're going to do now is we're going to build a circuit using our microcontroller, our Arduino microcontroller, where we're going to write some code in order to control our LED. Yeah, so we're going to show you exactly the same thing, but this time using embedded systems, show how we can do that using software, a combination of both software and hardware. Yeah, and by doing it this way, we will actually have more control over our LED. We'll be able to do much more things simply by controlling it via software. So first of all, though, what we've got to do is build our circuit. Okay, so we have our Arduino board here, but we also need our LED and our resistor. So what I'm going to do first is go to here to add parts. First of all, let's move this half of the screen out of the way. Let's move this to here. Let's build the circuit. Right, I'm going to place the circuit, I think, this time on a breadboard. See if I can find a breadboard. Half a breadboard, will that be enough? Probably. Okay, so that's a breadboard. Let's move it there. Okay, right. The second thing I'm going to need is an LED. Here we have it, our LED. And we're going to place our LED in our breadboard. Okay, I'm just looking, making sure that's correct. Yep. That's it. And then we're going to need a resistor. We don't want to put my resistor. We don't want to put my resistor. Let's put my resistor here. Oh, where's my? Oh, there it is. What am I doing? Come here, resistor. Okay, so the resistor is connected to the leg of the LED here. Yeah, that leg you can see is slightly bent. In this case, that leg is called an anode. Yep. Okay, and then so it's connected to the anode of that LED by this breadboard. And now I want to connect this here end of the resistor. I'm going to connect it to one of the Arduino pins, and the pin that I'm going to connect it to on this occasion is going to be pin 2, which is just about here. Okay, so pin 2 goes to this point here on the breadboard, and that point there is connected to the resistor leg there. It looks like it's not connected, but believe me, folks, it is. Under this breadboard, there's wire that connects, or tracks that connect A, B, C, D all together. All of this line is connected, then all this line is connected, and then all that line is connected, yeah? But they're not connected to each other this way, yeah? Horizontally. Vertically, as you can see it, they are connected, yeah? And then they're broken here, in this middle bit here, and then they're connected again down here, yeah? So that's why, although it doesn't look like it's actually connected within that line. Okay, and same there. Okay, and then finally, we've got this leg doing nothing. Of course, that leg also needs to go somewhere. It needs to go to ground. Remember, I did it with the other circuit. So if I put a wire there, that leg, then I'm going to move that down to this track here. Yeah. Now, these tracks here, they're actually connected that way, horizontally, not vertically. Yeah. So the two tracks here are connected horizontally, not vertically. That's the word I'm looking for. Okay. So now I've got ground on this Arduino, and I want to connect the ground here to the ground. Ground there, and so they should be connected. So believe it, folks. Hopefully, if I've got that connected up right, that's all I need to do in terms of the electronics. Yeah, electronics now is finished. Yeah, so you can see it's much easier to build than it would be if we were using discrete components, building and designing it, or designing and building it using these discrete components through electronics, solely electronics. Yeah, but with Arduinos and a bit of software, we can actually make things much easier. Okay, so that's the electronics for now. So I'm going to move that to one side. Yep. And now we're going to start on the software. Okay, so this is the Arduino software side. Those of you who are familiar with any high-level language, you'll kind of understand the concept what I'm doing if you've never done this before. Those of you who are familiar with C or C++ will know exactly what I'm doing. Those of you who are familiar with Python will kind of know exactly what I'm doing as well. Okay, so the first thing I'm going to do, I'm going to set up all my variables. I'm going to set them at the top here, and there's a couple of variables that I need for this, and that is there's a pin from the Arduino board, pin 2, which is going to feed the LED with an output voltage, yeah, and I've got to name that, and the type of variable it's going to be is going to be an integer, yeah. So int, and I'm going to call it red pin, yeah. I'm simply going to call it red pin, and I assigned the value of 2 because I'm on pin 2, yeah, semicolon. Okay, I think I may also type some stuff to or have a message displayed on screen. So I'm going to set up a bit of text, and I'm going to have to make that into a string. Yep. And I'm going to call it screen text. Yeah. And in quotes, I don't know why it's done that. In quotes, I'll type my message that I'm going to want to go to screen. I'll do that after. I'll just say, I'll just say for now, LED. Let's see, blinking LED display. Yeah, that's what it's going to be called. Actually, I could do a couple. Oh, I was thinking of a couple more. I'm going to do a delay. We're going to need to delay this. So let me just call this, make it into an int, and let's give it a variable name called sleep. And I think we're going to keep it off for about a second. In Arduino, we work in milliseconds, so let's keep it off for 2 seconds. So 2000 milliseconds is 2 seconds. Okay. Yeah, that should do for now. Right, in setup, what I want to do is set the pin, so the board knows that we're treating pin 2 as an output and not an input. So we simply do this, pin mode, and then we type in red pin, and then we are going to type in output, because it's an output. Yep. Because we're also going to be output into screen, with Arduino we call it a serial monitor. Yep. And so we need to set up the baud rate of the board communicating with the computer and the computer screen. So we do that by simply saying serial.begin, and the baud rate we're going to set up is going to be 9600. Yep, that should be fine. What else is there? I think that's about it. What I could do in setup, I can also now put in print to the screen straight away. So it prints once. So we can say serial print, and what we're going to print, we want to print screen text. Screen text. So it prints that to screen. So print, and then so there's a new line. Okay, print screen set. Okay, great stuff. Now in our loop, because we want the LED to go on and off forever, we don't just want it once on, then off, or on and stay on, or off and stay off. We want it on, off forever. Yeah. So we do a loop, kind of like a true loop that goes on forever. So what do we want to do here? Right, we need to output to our LED, and so we want to write to our LED. Sorry about that, guys. I kind of had a blank for a couple of milliseconds there. So we're going to do a digital write, because we're writing to our LED, And what we're going to write, we are going to write to our red pin, which is our red LED, red pin, and we want it high. Yeah. Okay, but how long do we want it high for? So it's going to go, at this point, our LED will go on. How long do we want it to go on for? Well, we want it to go on for 2 seconds. So we simply put our delay in here, and in C++, we have a function called delay. And within that delay, we will put enter sleep, colon. So it will be on for 2 seconds, and then we need it to switch off. So I've just copied and pasted the digital right there. Red pin is still high. Let's change that from high to what? Can you guess? Yes, to low. Change it to low. And we put the sleep in again, using the delay function. In fact, instead of having it equal on and off, so it's equal square wave, what we'll do is we'll have it off for a shorter period of time. So let's create another variable called sleep 2. And I'm just going to change that to an off of 1 second. So that's 100 milliseconds. So sleep, I put a 1 there. Okay, so it should come on for 2 seconds and then go off for 1 second. And since it's in a loop, it should repeat doing on and off at those times. Okay, let's just do that first. And before I do anything else, let's have a look at this. It's all it should be. And if we run it, we'll see what we will get. It's compiling, great stuff. And so in the compiling of this, it sees some errors. Yep. So there's an error there, there's an error here, and an error here. Well, the first error I can see straight away. That string should be capital. This here, I'm not sure what I was doing there. I put a comma when it should be a period. Well, still something else. Sleep 1. Oh, there's no sleep 1. It's sleep 2. Sleep 2. Okay. I think I'm looking through just to make sure. To me, that looks fine. I can't see anything at the moment. So let's try compiling this again. Downloading the software to the microcontroller. Oh, can you see it go on, guys? Off. On. Off. On. Off. Okay. So by just writing those couple of lines of code and just a resistor and a LED, we're able to do exactly the same thing that we did before using all those electronic components by just using a couple of LEDs, the microcontroller of the Arduino, and writing a little bit of code. Let me just do this also. So we know when it's on. We can also print to screen at the same time. So we can say serial dot print, and then we can write red LED on, red LED on. Yep. And we can also write red LED off. Yeah. 2 more lines of code. And then what I need you to do is when I run it is look at this screen here whilst you're looking at the LED and see if they work simultaneously in sync with one another. Okay, let's download the code and let's see what we get. So I'm downloading code to the Arduino. Okay, it's working. It's on. Red LED off, off, on, off. Okay, let me just do one other thing just to make it the formatting look a little bit better. Just going to put a new line each time. Let's run it again. Let's get rid of this first. Let's run it again. Let's see what we get. Red LED on. red LED off, red LED on, red LED off, red LED on, red LED off. Okay, guys? So that's using the Arduino and some basic components and a little bit of coding in order to control the blinking of the LED. I hope this helps, and I hope you found this all interesting. And if this is something that really interests you and you want to know more about it, either for yourself or for a young person, I may be running a series of workshops this summer. So if you are interested, let me know ASAP, and I'll see whether I will do that or not. Okay, guys, thanks for now. Have a great day.